Hi there, we're back today to talk about our last law of logarithms. And on our previous podcast, we talked about the product law, which just means if we had the log of some base a with x times y, that's the same thing as log base a of x plus log base a of y. And we also talked about the quotient law, which meant if we had log base a of quotient means divide, so x divided by y, and that's the same thing as log base a of x minus log base a of y. And we have one last law of logarithms that we're going to talk about today, and that is our power law. So let's just suppose now we have some arbitrary variable x, and that's equal to a to the m power. Well, we can rewrite that in logarithmic form by just saying we know that that is the log of base. We look at our base, so we have the log of base a of x equal to m. So now from there, we could go ahead and say, what if we are going to take x, this value x here, and we're going to raise it to the p power? Well, that just means we have a to the m still, and that a to the m now, which is the value of x, is going to be raised to the p power. Now, from our exponent laws, we know that this is the same thing as a to the m times p. So I can go ahead and rewrite this again. If we have x to the p, we know it's equal to a to the m times p. We can rewrite this in log form by identifying our base. So again, our base being a, and this will be now the log base a of x to the p equals m to the p times p. And if we look up here, we know what the value of m is. Our value of m is just log base a of x. So I could substitute that in. So I could say that the log base a of x to the p is the same thing as p here times our m value, this being our m. So log base a of x. So if we notice here, we can see if we have some value to the raised to a power, that power just comes right out front. So let's go ahead and apply this to a few examples. Now we want to express as the log of a power. Right now we have some product times, so we have some number times our log. If we're going to express this as a log of a power, and we can just think back to our rule that we just came up with of log base a of x to the p, we know that is p times log base a of x. We can apply this rule and say, well, I recognize now that my p value is just 3. So I could rewrite this as log base 2 of 4 to the third power. And that's it. That's written as a log of a power. Now do the same thing here. We can identify our power as being the product in front. So this could be written as log base 10. We don't have to say it because we assume it's there. So log of 9 to the x power. So just look for your little shortcuts here. This just comes out front. This comes up here to the top. Okay, next problem. Now they want us to express as a product of a number and a log. Well, that's easy. Again, thinking back to our power rule here, we have log base a of x to the p. That just equals, bring that power out front. That just equals p times log base a of x. All right, so again, identify your power, which is 5. Bring that out front, so we can rewrite this as 5 log base 4 of 16. And then here, identify your power, which is x. We can bring that out front. Now we have x log of 5. And we're done. One more slide here. We are going to simplify 2 log base 6 of 3 plus 1/2 log base 6 of 16. Well, first let's go ahead and take care of these powers. Since we recognize that we have 2 powers here, we can rewrite our log. We have log base 6 of 3 squared plus log base 6 of 16 to the 1/2. We can simplify within our log here. This is log base 6 of 9 plus log base 6 of 4. And now using our product rule, if we have the log base 6 of 9 plus log base 6 of 4, and they're attached with addition, it just means that this is log base 6 of 9 times 4, which is log base 6 of 36. And to actually evaluate this or simplify it to its fullest, we could say, well, we know that this is going to be our base of 6 to the what power is going to equal 36. And we'll know that that question mark is just going to be 2. So this whole thing simplifies to be 2. And we'll stop for now.